Java stack traces, debug class not found errors. Imagine trying to open a door and finding it locked. You know the door is there, but something is stopping you from entering. That's similar to what happens when you see a class not found error in Java. It can be confusing, but understanding the stack trace can help you fix it quickly. When Java runs your program, it keeps track of what it's doing with a stack trace. If a class is missing, the JVM will throw a class not found exception. The first line of the stack trace shows this exception and the name of the class it cannot find. The lines below show the sequence of method calls that led to this error. Reading from top to bottom, you can see exactly where in your code the JVM tried to load the missing class. This is your starting point for debugging. The next step is to check your class path. The class path is like a map that tells Java where to look for classes and libraries. If the class you need isn't in any of the locations listed in the class path, Java can't find it and throws the error. Make sure all directories and jar files containing your classes are included in the class path. For example, if you added a new library, verify that it's correctly referenced in your build configuration or command line. Third, verify your dependencies. If your project uses third-party libraries, ensure they are properly included. For instance, if you are using Maven or Gradle, check that the dependencies are declared correctly and that the versions match between compile time and runtime. Sometimes, a mismatch can cause classes to be missing when the program runs. Next, look for typos or packaging issues. Double-check that the class name is spelled correctly in your code, especially when using dynamic loading methods like class4name. Also, inspect your jar files to confirm they contain the expected classes. Sometimes, a build process might not package classes properly, leading to missing classes at runtime. Using your IDE can be very helpful. Most integrated development environments highlight unresolved imports or missing classes before you even run the program. Some IDEs also have tools to analyze your project's dependencies and warn you about missing libraries. Additionally, application performance management tools can monitor exceptions in real time and give detailed stack traces, making it easier to locate the source of the error. Finally, consider transitive dependencies. If your class depends on other classes from different libraries, make sure those are included as well. Missing transitive dependencies can cause indirect class not found exceptions, which might be tricky to spot but are just as fixable once identified. By carefully examining the stack trace to find where the missing class is referenced, then checking your class path, dependencies, and packaging, you can resolve class not found errors efficiently. This process is a key part of mastering Java debugging, helping you quickly identify and fix runtime issues by following the trail the stack trace provides.